Assalamualaikum. Bismillahirrahmanirrahim. Welcome to our Juniper Specialist level course. Our course name is Service Provider Routing and Switching. That is JNCIS-SP. It's a specialist level course, and the category is Service Provider. Okay, so we are now discussing Juniper service provider switching. In Juniper service provider switching, normally we use AX and QFX series switches, but MX series device have also switching functionality. So last day we discussed VLANs and IRBs, how to create VLAN or base domain, and how to configure IP addresses in layer 2 services to communicate remotely. Today we discuss module 4, virtual switches. Okay, as like virtual routing instance, that means we configure different virtual router in a single physical chassis, and that will work as a separate router. So you can also configure virtual switches. You can configure multiple virtual switches in a single chassis or single physical devices, okay, if you want. So first we discuss theoretical concept of virtual switches, and next we configure the lab. So let's start. Today's topic is virtual switches. Okay, so this is our first slide. Let's start. This virtual switches are basically three module or three section. One section is routing instances, another is working with virtual switches, and last one is virtual or routing instances and logical systems. Okay, there's some difference in routing instance and logical system. We'll discuss on that section. Okay, first let's start routing instances. Okay, routing instances basically if you need multiple or device in a single device, like you can say it's a virtualization. You can say it's a virtualization. You are just one single server and you want to make multiple VM virtual machine or container from that single physical chassis or single physical server. Okay, this is the similar concept in Juniper VMX or MX. You can configure multiple virtual routing instances, and those virtual routing instance you can configure to act as a router, to act as a switch. So today we discuss how to create virtual switch using routing instances. Okay, so see this one. This is a MX240 router. Default chassis. This is the default chassis. So default, you can configure this MX240 as a router. In the same time, this device will work as a default switch. Okay, that means you can configure some port as a layer 3 port, and you can configure another port or a specific port as a layer 2 port. Layer 2 port will be in default switch and other port will be in default chassis. Okay, that means in routing, default routing instances. Okay, so let's see here, MX240 layer 3 interface only logical view, and by default If you configure multiple interfaces, those interfaces, network, or if you configure dynamic or static routing, everything will be in inet.0. That will be happen based on your layer 3 interfaces. Okay. So another is Mac table or default switch. If you just configure some interface as a layer 2, those interface making the Mac table and those interface will be in default switch. Okay. It like VRF in Cisco. Yes, it's a VRF Lite. In Juniper, called routing instance, and Cisco called VRF. Okay. This is the similar to VRF. Okay. To create multiple and isolated routing table on a single router is perfect. Okay. So see this one. This one already we discussed in routing section. Okay. Just we configure multiple interfaces under single routing instance. See here, and the routing instance name is VR1 and instance type is virtual router. Instance type is virtual router, and attaching this connected interface and configure the any dynamic routing or static routing protocol. So under this VR1, which interface participate, they are making their table individually. This table is completely separate from other routing table, including default routing table. In default routing table cannot reach specific VRF table or specific virtual routing table. Okay, this is completely separate. inet.0, this basically same concept. Example of virtual switch routing instances. Say here, show bridge domain. This bridge domain, we use bridge domain in MX series router to create the VLAN ID. Okay, and attaching the VLAN ID in access port and allowing the VLAN in trunk port. So we have to create the VLAN ID. VLAN ID will be created under the bridge domain. Under the bridge domain. See here, there are multiple VLAN IDs here 100, 101, 102, 103. All VLAN ID and directly connected interface is in default switch. Is in default switch. Okay. So if you want to make separate virtual switch, the configuration process is just set the routing instance name, and you have to mention the instance type, routing instance type. Routing instance type will be virtual switch, not virtual router. When you make when you want to make virtual switch, instance type should be virtual switch. Okay, this is the first consideration. And other consideration is similar like default switch. Just create the bridge domain. Under bridge domain, you can create the VLAN ID list or single VLAN. You can create single VLAN or VLAN ID list and attaching the directly connected interface. Which interface will participate in this virtual switch? So VS1, this is the virtual switch 1, and VS switch 2, this is the virtual switch 2. In VS1, your connected interface is attached 0, 1 and 2, and VS2 you are attaching 3, 4 and 5. This is the another interfaces is attaching another virtual switches. So now you have three virtual switches. Number one VS1, number two VS2, and another one is virtual switch default or default switch. Okay. So these are completely separate. Completely separate. BS1 cannot communicate with BS2 or default switch by default. Okay. So then, so now we need to configure and verify virtual switches. How to create the virtual switch, how to create the bridge domain and VLAN, and you can assign the interfaces also. Okay, so check this one. This is my topology. Very simple. Switch 1 and switch 2, only two switches is connected with each other and to PC for check-in. Okay. Okay. Let's show bridge domain. See here, in last class, we have created two VLAN under bridge domain. Under two bridge domain. One is bridge domain 100, another is bridge domain 200, VLAN ID 100, 200, and this is the addressing interface. Okay. And the routing instance is default switch. Routing instance is default switch. Okay. Default switch. So if you want to make another virtual switch, so how to make this one? Edit routing instance, and you have to set the instance name. You have to set the instance name. Like I said here, virtual switch SW1, virtual switch 1. Okay, then under virtual switch 1, under virtual switch 1, you can create VLAN. You can create VLAN like this. Okay, set the bridge domain and you can set the VLAN ID. You can set VLAN ID or VLAN ID list. Set bridge domain. My bridge domain will be like bridge domain for VLAN like 101. 101 and VLAN ID or VLAN ID like 101. So you are just creating instance type virtual switch. See here the warning. Warning is I'm just making the routing instance. Routing instance is virtual switch 1 and creating the bridge domain. Bridge domain name is bridge domain 101 and bridge domain VLAN ID is 101. So the warning is bridge domains configuration only be used for instance type virtual switch. When you configure the instance type virtual switch, then you can create the bridge domain. So set instance type. There is multiple instance type. Okay. So we need to create the virtual switch. So our instance type should be virtual switch. Virtual switch. That's perfect. No warning is here. So first one is instance type should be virtual switch and create the bridge domain. Next, Next, you have to add the interfaces. So which interface will be in your configured virtual switches. So in switch 1, there is two interfaces. One is 0, another is 1. Another is 1. So you can set this set interface. My interface name is ZE dash 0 by 0 by 0, and another is 1. 0 by 0 by 0, another interface is 1. So you have completed virtual switch. So there is basically three steps. Step 1, you have to set the instance type. Step 2, create the VLAN. Step 3, attach the specific interfaces which will be in virtual switch 1. So commit check, it's okay. And this interface C0 by 0 by 1, this interface will be in access mode and this interface will be trunk. So checking the configuration, I think those configuration already done in last class. C0 by 0 by 0. Show family breeze, interface mode trunk, and this is the allowed VLAN. Perfect. Edit interface. Z is 0 by 0 by 1. This will be access port, and the VLAN ID. Allowed VLAN ID, single VLAN ID. And you can just commit this command, run show breeze domain. Breeze domain. See here, breeze domain. Another breeze domain is here. Another breeze domain is here. Breeze domain 1. Breeze domain 1. And the breeze domain name is breeze 101 and the VLAN ID is 101. So breeze domain, uh, you can set the breeze domain name, or you can set the instance. Our instance is BSC is 1. See here, BSC, only BSC is 1. You can see here only BSC is 1. This interfaces. So this is the configuration basically. And after configuring versus 1 and versus 2, you will get these changes. Okay, under virtual switch 1, you will get the bridge domain and the VLAN ID. Okay, so next forward, it's basically question and answer section, Q and answer section. What are the attributes of a routing instance? Routing instance. Routing instance, its own routing configuration, its own routing tables, interface belonging to those routing tables. That means one single routing instance that have their own routing configuration. Edit routing instance. Routing instance is PSVs1. This own configuration. Other one is its own routing tables. It's a basically switch, virtual switch. So it's have MAC table, interface belonging to those routing tables. So these are the attribute of routing instances. What are the two routing instance types? Virtual router and virtual switch. Virtual router and virtual switch. So you can see this easily. Okay, these are the routing instance type. See here virtual router and virtual switch. For Layer 3, logical or virtual router. You can add the virtual router. For layer 2, that means you want to create logical virtual switch, you have to set the instance type is virtual switch. So virtual table, virtual interfaces, these are not the instance type. Instance type is virtual router and virtual switch. So now we'll work with virtual switches. Again, configuring a routing instance. This is the basically step which we have already done. Configure a base virtual switch routing instance. Start by creating the routing instance, giving it a name, and entering the configuration mode. Okay, so edit virtual routing instances. Routing instances name is virtual switch 1. You can set any name. Name is user defined. Okay, name is user defined. Define the instance type. Set instance type virtual switch. You have to mention this. Instance type will be virtual switch. Last one is define the interface associated with this routing instance. And you have to mention the interface. Which interface will be on that virtual switch routing instances. Then commit and show the command. Run show route instance or run show route. Routing instance, this is the example, VLAN ID, bridge domain, multiple bridge domain, sample configuration. This is the interface configuration, access port configuration basically. This is the trunk port configuration we have already done. And this is the IRB interface we have already done. How to configure the IRB interface. Okay. And this is the all configuration in single screen. Instance type, bridge domain, layer 3 IRB interface, and directly connected interface. And this is the output. So I have configured this virtual switch in single switch in switch 1. We configured this in a switch 1. Switch 1. Okay. So we need to configure switch 2 also. Edit, set, show display set relative, and the command is this. Say here the interface is same. Trunk interface is G, access interface G0/0/1, and the same interface. So just copy the command and paste here. Okay. Run show bridge domain. I'm not getting associated interface. And show bridge domain. This should come here. Virtual switch 1 is coming, bridge domain is coming, but addressing interface, not showing the addressing interface. Added to the correct routing instance, bridge domain, and VLANs. Okay. So next we have to check the VLAN ID, addressing VLAN ID. So I'm creating VLAN ID 101 in virtual switch 1 and addressing Z0/0/1. This interface, I think, will be in VLAN ID 100, maybe. This is trunk, basically. So we have to set unit 0, family brace, VLAN ID list, have to add 101. Okay, so 101 is added here. Exit, edit interface, GE 0 by 0 by 1. So set unit 0, family brace. Family brace, VLAN ID will be 101. VLAN ID will be 101. Okay. Now access port configuration modification done. Run show brace domain. See here, interface is coming, addressing interface. So this was the misconfiguration. Under virtual switch, you have to correctly attach the VLAN ID. Edit interface G 0 by 0 by 0. Now VLAN ID list 100. So set here your new VLAN ID 101. Unit 0, family brace, VLAN ID list will be added 101. Perfect. Edit interface GE 0 by 0 by 1. Set unit 0, family brace, and VLAN ID will be 101. 101. Perfect. Yes. Then commit. Show brace domain interface under virtual routing instances. See here, interface is now virtual routing instances. Okay. So when PC1 send packet to PC2, they are using not the default switch. They use virtual switch to communicate from one to another. Okay. So this is the configuration of virtual switch and verification. Show route. If you configure the IRB interface, then you can get this one, the route table. Show route instance. Route instance, you will get basically single routing instance. And show route instance. Our route instance is versus is 1. Versus is 1. Single route instance. Okay. Show routing instance. You can also set this command. This is just configuration verification. Show routing instance. Routing instance name is vSwiss1. You will get all configuration regarding virtual sys1. Okay, this is simple. And again, we are in Q&A section, question and answer section. Which statement best define an IRB interfaces? IRB interfaces, it's a basically layer 3 interface, okay, where we configure Swiss management IP addresses, okay, IP gateway for a bridge domain, routing instance for a virtual Swiss. We're in last section, routing instance and logical system, okay, routing instance and logical system. So see here, when you configure the routing instance, physical in a routing perspective, physical router route table is id.0, but in logical or routing instance route table will be instance name.inet.0. Okay, if you want to attach global route table with virtual route table, I cannot see your screen. I think my internet connection is okay. Everyone have same problem. You cannot see my screen.
No, we can see your skin.
Okay, but so please check your internet connection, Vishwajit. Please check your internet connection. I think it's an
Internet
internet issue.
connection is okay, but
Uh-huh.
is it any problem in you? I mean, in a screen, you are.
Uh,
I see only your name, but
okay, I think if you are in Zoom, like I can just see you to see just my name here, right?
yeah.
You can pin this one, my presentation. You will just pin my presentation. I think it will be okay. Maybe it's a Zoom setting issue.
Zoom is version change or something.
Okay, reconnect. Just
Leave and
disconnect
reconnect.
yourself. Yes, disconnect yourself and reconnect. Okay. So just consider you have two route table. One is inet.0 that will be happened based on your global route table, and another route table name is instant dash name dot inet.0. That is basically another virtual routing table. Another virtual routing table. If you want to communicate from global route table to another virtual route table, you can consider a logical tunnel to communicate one route table to another route table. Also, you can consider physically loop. Physically loop means you can connect one port with another port. One port will be in physical route table and another port will be in virtual route table. Okay, thank you. Okay, this is the basically two solution. If you want to interconnect different routing table, different routing instances. It can be global to customized routing instances, or it can be customized routing instances to another customized routing instances. Okay, so if you want to use logical tunnel, if you want to use logical tunnel to interconnect between different virtual routing instances, you can add this tunnel services in APC. You have to add the tunnel services in APC. And after configuring tunnel services in APC or SASIS, you will get the LT interfaces. That means logical tunnel interfaces. How to make this one? Just I show you. See, in switch to see here, run show interface stars mesh LT dash. There is no LT interface here. LT means logical tunnel. There is no logical tunnel interfaces here. Okay, how to make the logical tunnel interface? First, run show chassis hardware. You have to check the hardware. Your APC 0 based on your device model. Okay, check the APC number. See here the APC 1, but my APC is 0. Okay, so another PIC here, PIC is 0, my PIC is 0. Okay, so when I configure the tunnel services, I have to mention APC 0 and PIC 0. Okay, then tunnel services and assign the bandwidth. Assign the bandwidth based on your model, based on your device model. You can set the tunnel interface bandwidth. It basically depends on your requirement. If you want to travel um, 10G traffic from one virtual routing instance to another virtual routing instance, you can take more than 10. Okay, more than 10. So it depends on basically your production requirement. Okay, now for lab, I set here 1G, set SASIS. This configuration is in under SASIS. Okay, set SASIS APC 0, PIC 0, and the tunnel services allocate the bandwidth. The bandwidth is 1G, 10G, up to 40G. Based on your device, you will get more than this. Okay, not 40G. You can see 100G or 400G. Okay, so I said here 1G because it's a lab. I mean this one. So check again the LT interface. Getting LT interface is coming here. LT interface is coming here. Okay. So this is the way to create the LT interface in Juniper MX series devices. So you can use this LT interface. You can use this LT interface between global route table and customized route table to interconnect between them. Say it's an example. This is the virtual router one. Virtual router one, the LT interface is this is the main interface dot one, that means unit one, and another and see here the configuration syntax is like this. Um, See here the unit 0. Unit 0, you have to set the encapsulation type. Encapsulation type VLAN, and the VLAN ID is 100. Peer unit is 1. Family INET. This is the IP address. One side IP address is standard 1. Another side IP address is standard 2. Just point to point. Just making point to point between two router. Between two router. In one side they are using the unit 0, another side using the unit 1. They are just pairing unit 0 with this unit 0. This is my PR unit and this is my PR unit. Okay, so this is basically sample configuration of LT interfaces. If this is layer 2 physical loop. Okay, just consider you are just making it's a default switch, and this is the virtual switch one. Consider two different physical interface. One physical interface is attached in default switch, another physical interface is attached in virtual switch. You want to communicate from default switch to virtual switch. How to make this one? Just under routing instance in default switch under routing instance, you 1 by 0 by 4 if you configure 1 by 0 by 4 as a layer 2 interface, this will be automatically in default switch. If you attach this port under virtual switch, just attach this interface under the virtual switch. That is okay. This interface will be in virtual switch. Okay. Other step is as like before. Okay. Nothing changes. Another checking or verification is similar. And now we'll discuss logical system overview. logical system overview. So say here, this is multiple router 1 and router 2. They are connected with switch 1 and switch 2, and there is multiple router. So this is basically you use your multiple router for multiple services, multiple router for multiple services. If you if you want to virtualize your physical router, if you want to virtualize your physical router, you can do it. Okay, like you can divide this router 1 as a logical router, when you configure the logical router, you can configure multiple logical router. You can configure multiple logical router. So in that case, one single physical router will work as a multiple router. Okay, this is the logical router concept. And logical system have some abilities and limitations. See here, logical system 16 commit cannot configure more than 15 logical system. That means it's a limitation. It's a limitation. Logical system have limitations. Okay. You have to configure maximum 15 logical router. A maximum of 15 logical system can be configured. Offer routing and management separation is logical system has its own routing table and can contain its own routing instances. Okay, one logical router, under logical router, you can configure multiple routing instances, and those routing instance will be under the logical system. That means virtualization, then virtualization, nested virtualization like this. Physical router, then you create the logical router. Under logical router, you can create the routing instances. Okay. Management separation means multiple user access, and logical router support OSPF, ISIS3, BGP, RSPP, LTP static routes, IPv4 and IPv6 servers. But these have some limitations. Logical router have some limitations. First, one limitation is you cannot configure more than 15 logical systems in a single physical router. Okay. And other limitation is some high availability feature like non-stop routing, non-stop browsing, unified ISSU. This is the limitations. Not possible, not supported. Under logical system, you cannot apply the PBR, that means RPM probe. You cannot configure this one. Okay, there is multiple limitation in logical system. Okay, but you can configure graceful restart in logical system. So check now logical system. How to check this one? Logical system. Set logical system like logical system 1, logical system 2, logical system 3, logical system 4, logical system 5. Now commit this one. It's okay, no problem. Okay, then create more. 6, 7, 8, 9, 10. Then commit. It's okay up to 10. Then create 11, 12, 13, 14. Commit. Also okay. Then 15. Commit. Also okay. Then create 16. Then set commit. Cannot configure more than 15 logical system. So it's a limitation. But in routing instance, there is no limitation. Okay, you can create multiple routing instances. Okay, so delete 16. Delete logical system style. dot star. No. Regular expression will not work. No, not work here. Okay. Oh, that will be work. Wildcard delete. Wildcard delete will be work. I think logical system, and set the name logical system and dot star. Yes, and this is called wildcard delete. All logical system deleted from here, I think. Yes, all logical system deleted from here. This is called wildcard delete. If you want to delete more than single, or you can delete multiple, you can set the regular expression. Okay. So next, this is the logical system. Under logical system, you can add multiple interfaces. And interface will act as a layer 3, act as a layer 2. Okay. If you configure a logical system in physical interface, the VLAN type will be the flexible VLAN tagging. That means I want to say, see here, our interface is Z0 by 0 by 1. Consider one Z0 by 0 by 1. Another switch is connected here, or you can say like this. It's a router. One interface is connected with switch. So if you want this router as a logical switch, so this interface, consider here there is multiple VLAN. There is multiple VLAN. So you just configure logical system. Under logical system, one or multiple VLAN under in like, what want to say, like the example is you are just attaching single physical interface in under the logical interface. Okay, the interface is act as a layer 2 port, and this is the allowed VLAN, multiple allowed VLAN. Basically it's a trunk port. When you configure under logical system, you have to configure this interface as a physical chassis flexible VLAN tagging. Flexible VLAN tagging. This is the another consideration. Okay. So this is under the logical system. Under logical system, you can create bridge domain. Under bridge domain, you can create multiple VLAN ID. You can configure the access port. You can configure the trunk port as we configured in our lab, and you can check. Okay, so those configuration will be under the logical system, so this is one step. So see here, this is chassis logical system 3, and this is the logical system 4, and the another logical system 5, and this is the another logical system 6. So you can create a multiple logical system and interconnect based on your requirement. Based on your requirement, you can interconnect one logical to another logical system. Okay, so logical system, this is similar example. I want to show you, this is basically finished, but I want to share you one thing. Under logical system, and just see here, edit logical system. So first one, I just delete this one. Okay, routing instance, this is one. I delete this one. This one is deleted. Okay, and show display set. Show display set. Display set. I want to create virtual routing instances under the logical system. Okay. Okay, so edit logical system. Now I'm in logical system 1. Okay, so similarly, edit logical system 1. Under logical system, now creating virtual switch. Now creating the virtual switch. Okay, now creating the virtual switch. So in virtual switch, I'm attaching two interfaces. The instance type is virtual switch, and this is our VLAN ID. Okay, so configure this one. Similarly, just copy this one and paste under the logical system. So your configuration is in logical system. So say here, warning, only interface with interface mode is allowed in a virtual switch. So this interface under default, that means this interface will not under the logical system. This Z0 by 0 and Z0 by 0 by 1, this interface not present under the logical system. This interface is in the default configuration. See here, 0 and the 1. So this interface will be in under the logical system. Okay, so delete this one, unit 0, delete this one, delete this interface also, and go to the logical system and copy this command, copy this command trunk, and you need to add single VLAN ID. No need to take everything, and this is another interface which is access. Okay, see here, this is your interface and this is your routing instances. There is no error. There is no error. Okay, so commit check. Your configuration is okay. Run show base domain. Run show base domain, and see here. Commit this one first. Run show base domain. See here, versus switch 1. Your physical interface is here. You can set logical system here, logical system 1. See here, under logical system, this virtual switch is in under this logical system. That means first one, consider the physical router, then you create the logical router, one virtualization, and under logical router you are creating the virtual instances. That means nested virtualization. It is possible. Okay, so just go forward. And last question and answer section, why should the tunneling services be enabled while using layer tunneling? Basically, for layer tunneling, we are using the MX series router in our lab. Okay, what are the abilities of logical system? The abilities of logical system, you can say some high availability features are not supported. Maximum 15 logical system can be configured. Basically, our first answer is incorrect. I think this is wrong. Delete this one. Only two question. What are the abilities of logical system? Logical system abilities, management separation means multiple user access can be configured. So you can configure multiple user. Just consider you are creating 10 logical system in a single physical router. You can create 10 individual user and assign those user in a specific logical system. Those user can log in and work with a specific logical system. Okay, that will be um, that will be possible. Okay, and another one is a maximum of 15 logical system can be configured. Okay, this is the you can say it's a limitation, but in routing instance there is no limitation. So just summary today's topic. First one is how to create the logical switch. How to create the logical switch. First, if you want to create the logical switch, just go to the routing instances. You have to set the name and set the instance type, and you have to add the connected interface. So it will be on that logical or on that virtual switches. Okay, and you can create a bridge domain, you can add VLAN ID. Okay, it's like this. And another one concept is the logical system. So in your physical router you can create 15 logical system. Under the logical system you can create also the virtual routing instances. So I think we have done our today's topics. If you have any question, you can ask me. Is there any confusion? Nothing. Okay, that's good. So bye bye. Allah Hafiz. Stop.
Love is.
Okay. Arif, Altaf Ali Shiblu। আরিফ শুনতে পাচ্ছ?